Alright, in this video I want to demonstrate a couple of things here. I want to first, with this given function of 4x squared plus 3x, that's what f of x is equal to, and given that some random variable here, a, is equal to -1, right? So we're also told that a is -1. They want us to find the first derivative of the function at a. Right? What is the value of the first derivative at a? Well, again, our a is a -1, so we're really trying to find, right? We're really trying to find this. We're really trying to find the first derivative at -1. Okay. Well, and the second thing too is we're going to try to find the equation of the tangent line at -1. What they didn't give us, though, and I wish they had done this, I wish they had given us a coordinate. Instead of just one value, a of -1, why don't they give us a coordinate? But we can figure that out pretty easily. See, so what we have is we have some x value of -1. What I don't know is I don't know what this y over here is going to be just yet. So I wish they had given me a point. But we can figure that out pretty easily by plugging in -1 into our original function, and that will give us what the y value is going to be over here. Alright, so let's just figure that out for a quick second here. Not the first derivative, but what is f of -1 for my original function? So I'm going to plug in, anywhere I see an x, I'm going to plug in a -1 and solve this thing out here, okay? So -1 squared is +1, and +1 times 4 is still just 4, and 3 times that -1 is just a -3, so I really have 4 minus 3, which is a 1. Hey, that is the y portion of my coordinate. So I now have the full coordinate, right? Not just the partial coordinate, not just the x, but also the x and the y. Or this is going to come in handy a little bit later on, especially when I need to find the equation of the tangent line. Okay, quick review here too before I go off and find what the slope is. All right, and I've shown this in a previous video that I recorded. I like to use, if you don't know how to take a first derivative, but you just learned how to find the limit as h approaches 0 for our difference quotient, this formula here gives us the slope of the tangent line. Okay, so we're going to use this, since that's what we're trying to find is the first derivative. We're going to use that here at our given x. In this case, our x is going to be a -1. Here, let me show you what I mean. I already know what this is. I already know what f of x is. They gave that to us, right? It was given to us at the beginning. So let's go off and find out what f of x plus h is. Let's go find that next. Okay, it's going to take a little bit of work here, but we can do this. It's good old algebra. Fun with algebra here. Alright, so I know what f of x is. That's simply 4x squared plus 3x. That was given to us at the very beginning. Okay, now let's go find what f of x plus h is, because we need to know that. Alright, we need to be able to plug that into our difference quotient. Alright, so anywhere I see an x, I'm going to, instead of x, I'm going to plug in this thing here, which is x plus h. So anywhere I see an x, I'm not going to plug in x, but I'm going to plug in x plus h. And I need to work this out. So let's see, please excuse my dear Aunt Sally. PEMDAS says I need to take care of this exponent right here first. Alright, so I need to FOIL x plus h, which I hope you can see is just going to be x squared plus 2xh plus h squared. Should have written that a little bit bigger. Plus 3, I might as well distribute while I'm here, plus 3x plus 3h. And I have one more distribution to do, and that is I need to distribute this 4 times everything in this parentheses after it. So down here at the bottom, my f of x plus h is this big, long polynomial. Ready? Here goes. It is 4x squared plus 8xh plus 4h squared. Okay, so that takes care of this distribution right here, right? And then plus, don't forget my plus 3x plus 3h. Wow, that's huge, right? That's huge. But I think I've got everybody now. I've got all the players that I need for this difference quotient. I know what my f of x plus h is. I know what my f of x is. And I now have my h. That's simply, I'm just going to eventually try to plug in 0 for h. Okay, so here goes. I've got the first derivative is equal to the limit as h approaches 0. You ready for this monstrous fraction here? It is the f of x plus h, which we just found a second ago. That's this big long thing, 4x squared plus x 8xh plus 4h squared plus 3x plus 3h. Alright, so there's my f of x plus h. That is really huge. Alright, minus my f of x. Alright, minus my f of x. But my f of x, which we were told a second ago, is 4x squared plus 3x. Now I'm putting this in parentheses on purpose. Right? I'm putting that in parentheses on purpose because this negative sign here, this minus sign, affects both of them. Right? Both of these terms, or all of these terms that come after it. Now the bottom of all that is just a simple little h. Well, let's work this out a little bit more here. I've got my limit as h approaches 0. And inside here, I hope you see, I have 4x squared plus 8xh plus 4h squared plus 3x plus 3h. And here's where I get to distribute the negative now. Minus 4x squared minus 3x, because that minus now gets applied to both of those terms. Okay, very, very important. All over h. Well, can I simplify anything in the numerator? I hope you see that I certainly can. Look, this 4x squared at the beginning, which is a positive 4x squared, and that negative 4x squared cancels out. This 3x and that negative 3x cancels out. So the terms that I'm left with in the numerator, my 8xh plus my 4h squared plus, don't forget that 3h is still in here, right? That plus 3h. Do you notice that all those terms in the numerator have an h in common? All of them do. Which means I can take an h out. I can factor out an h from everybody up top, leaving me with 8x plus 4h plus 3 all over h. Now I can cross out these h's here. This h up front and that h on the bottom. Why would I want to do all that? Again, I'm trying to replace h with 0, right? Anywhere I see an h, I'm trying to replace it with a 0. And if I tried to do that right now, down here, I couldn't do it. So that's why I factored an h out of everybody there. And I'm simply left with this. I'm simply left with the limit as h approaches 0, right, of 8x plus 4h plus 3. Wow, that big, huge fraction. Remember that big, huge fraction that we had to start with? Now it just shrinks down to this right here. Oh, so much prettier, so much cleaner. And even better, now I can simply replace this h here with a 0, which means that this term is gone. Right? That's just going to be a 0. 4 times 0 is just 0. So I'm simply left with 8x plus 3. All of that work for that simple little 8x plus 3. Well, all right. What I was given, remember at the very beginning, I was given an x value of -1, right? There it is, x value of -1. So I need to put that in place of x here, which I hope you see just leaves me with, right, if this is a -1, I've got 8 times -1 plus 3, or -8 plus 3. I have a final slope of -5. That's going to be the slope of the tangent line, -5 right there. Okay? So now here's what I've got. That answers part A of my question. And part B, to find the equation of the tangent line. And I'm going to use the point slope form, which is this one right here. Hope you have that memorized by now, and if not, memorize it soon. That's called the point slope form of an equation of a line. Okay? So I have all the players that I need. I know what my slope is now at that given point. Remember, we just found it. My slope was -5. And I was also given the point -1 as my x, and I substituted that into my original function to find out what my y value is. So I've got a point and I've got the slope. Alright, so let's substitute all that in. I've got y minus, the y value was a 1. The slope was a -5. X minus my x value was a -1. And I'm going to clean all this up a little bit more here. I'm just going to leave this as y minus 1 on the left side. this right here minus the negative is really x plus 1. Really, that's what that is going on inside here, right? And distributing the negative 5 to both of these gives me a negative 5x minus 5. All right, one last thing. Let's just add 1 to both sides, and my final answer for the equation of the tangent line at a given point of negative 1 comma 1 was, or is, y equals negative 5x minus 4, right? So I'm simply just adding 1 to both sides here, just adding 1 to both sides. That's all I'm doing. Final answer, there we go. Hope that helps.